Girls, can someone read out, okay, ladies, this is exercise 13.5. We're continuing from question 2F. The lesson has already started. You need to get question 1F, 2A and 2C from some other students. Question 2F, a piggy bank contains only 5-cent and 10-cent coins. 8. So if it contains 48 coins, what have we got? A piggy bank has only 5-cent and 10-cent coins. If it contains 48 coins, yep, with a total value of $3.45. How many of each type? How many of each type of coin? Okay, I know you want to do 2C. One second. Shh. Question 2F, a piggy bank has only 5-cent and 10-cent coins. If it contains 48 coins with a total value of $3.45, how many of each coin? Girls, if X is the number of 5-cent coins, just be careful, it's not the value of the 5-cent coins, it's the number of them. And Y is the number of 10-cent coins. So wouldn't you count how many 5-cent coins? I've got 10 of those, so that's 10 times 5 cents. I've got 50 cents. Or I might have 20 of the 10-cent coins. So that's how you count your money. How many 5s do I have? How many 10s do I have? You put them into bundles and then you work out what you've got. Same thing here. So the value of the 5-cent coins, so if X is the number of 5-cent coins and Y is the number of 10-cent coins, what could be my first equation that I set up? Yes. It's seeing how many coins you've got. Shh. X plus Y is 48, equation 1. Because your piggy bank contains 48 coins. Now, how do you work out the value of them? Pretend you've counted all the 5s. Isn't it 5 cents times the number of 5s will give you the value of the 5-cent pieces? So, yes, it's 5. Now, I'm working in cents. So, 5 times how many 5-cent pieces gives me the value of all the 5-cent pieces. Because if there were 25-cent pieces, isn't that $1? So 20, if X was 20, for example, because it's 5 cents, you're trying to work out the value. It's saying a total value of $3.45. So 5 times how many 5-cent pieces will give you the value of the 5-cent pieces. Plus 10 times the number of 10-cent pieces. If you had 30 10-cent pieces, it would be 30 times 10 cents is $3. Does that make sense? So it's 5 cents because each 5-cent piece is worth 5 cents. So it's X, how many 5-cent coins you've got times 5, plus 10, which is the value of the 10-cent coin times how many are there, equals what? 345, and I'm working in cents. Girls, because I'm sure you don't want simultaneous equations with decimals. All right. I would substitute here. I mean, look, you can, unless you want to do 48 times 5. I would substitute here, girls, because you've got X and a Y on their own in that first equation. It doesn't have to be that they're both on their own, just one of them. And it's good to practice the method. So rearranging equation 1, I don't mind if you make it X equals or Y equals. Which one do you want to do? X equals 48 what? Minus Y, and then substitute that into, you know, sometimes it's easier to eliminate because it's still going to be horrible. Substitute into 2. So what do you've got? 5. What do I do now?
48
bracket 48 minus Y plus 10Y is 345. You know what? I think elimination's still probably easier, but it's okay. So let's go. What's 48 times 5? You've got to do it with either method anyway. No, it's 240. That's okay. Shh. Okay, so girls, 240 minus 5y. Remember, we're opening up that bracket. Shh. So, well, what have I got? Minus, well, isn't it, yeah, I'm just going to keep the plus 5y there, and I'm going to keep the 345 and take this 240 over. Are you okay with that? So I've done those two together is plus 5y, and I'm going to take the 240 to the other side and make it minus 240. Girls, that is a positive 240 on this side. I don't care about the minus after. Whenever there's a sign after the number, it doesn't belong to that number. That minus belongs to the 5y, not to the 240. That is a positive 240, and the opposite of it is a minus 240. So what have we got? 5y is 105. Y is
21.
21. So therefore, substitute y equals 21 into,
Don't you just say 48 minus 21 equals?
yes, into which one? Into x is 48 minus 1. I'm going to put it into this one. Same as 1. It was the rearranged one, which is 48 minus 21, which is 27. Now, of course, we're going to check this one because it's going to help you make sense of it all. So if x, so there you write nice and big, x is 27, y is 21. You would only write that if you've defined what it is, or you should say 27 5-cent coins. You should really say you've got 27 5-cent coins and you've got 21 10-cent coins. And girls, when you write it like that, let's just check our answer. 27 times the 5-cent coins plus 21 10-cent coins. See how I'm checking? So you need to, on your calculator, 5 times 27 plus $2 plus 210 cents. 5 times 27 is 135 and 210. And then you can feel confident. Shh, girls. If you've got one of these, just that quick check with your calculator. All right? Into the other equation. Because we substituted into 1, or the rearranged one, you check in equation 2. Okay, so I got my answers and I thought, let's see if that's true. If I've got 27 5-cent coins, aren't they worth 27 times 5, which is 135 cents? And if I've got 21 10-cent coins, they're worth $2.10 or 210 cents. And I get 345, which was correct. Shh. Girls, the other one I asked you to do was 2 what?
Miss, but if you just said, oh.
Do this correctly. So you can use the one type of pronumeral here if you want. I probably would. I wouldn't use 2 pronumerals. If I've got that this is x, what are you going to call the other?
3x.
Yeah, so if you do that, you use one type of pronumeral only. Look, this and age problems, I prefer to use one pronumeral. So x and 3x, it's much easier. One type of pronumeral for this one. Now what do I do? Yeah, good. So x plus 3x plus x plus 3x is?
112.
So girls, shh, with certain types, I think it's easier to use the one pronumeral. It's so much easier.
8x equals 112. And the rest of
Yeah, 8x is 112. X is 112 divided by 8, which is 16, 14. So therefore, I'm trying to think. So therefore, if x is 14, what's 3x? 14 times 3 is 42. So let's just see if this works. So what have we got?
42 plus 42.
We've got 14 plus 42 plus, this is our check, plus 14 and 42. You could just do 2 lots. Is it right? It's 112, therefore it's correct. Therefore, the width, what's the width? Shh. The length? 42. Shh. Girls, did anyone try it with x's and y's? Shh. Right. Girls. The adjacent sides in a parallelogram are in the ratio of 3 to 2. And the total perimeter is 150. Now that's the ratio. I'd use one pronumeral. Yeah, you can try that. This could actually be done by ratios. But girls, which side looks like the longer one to you? The one down the bottom or the one there? Now it's the ratio 3 to 2. So it's actually not 3 and 2. You would call it 3x and 2x. All right.
Which one's the width and which one's the length?
The length is the longer one, and the shorter one's the width in a rectangle generally. Long, length. All right, so girls, here's my parallelogram. Obviously the bottom, girls, please. Obviously the horizontal lines are longer. So if the ratio is 3 to 2, it doesn't mean the side lengths are 3 and 2. It means if this one was 20, that one would be 30. Does that make sense? All right, now it's 3 to 2, but 3 times something and 2 times something. It's because let's say if it was 30 and 20. Let's say it was 30 and 20, girls. How do you simplify that ratio? Divide both by 10 and you'd get 3 to 2. Let's say it was 9 to 6. Divide them both by 3. Shh, girls. You get 3 to 2. Ladies, it's the ratio of the sides, it's not the actual side lengths. So we put 3x and 2x. Do you get that idea? Whatever numbers you're going to end up with, they will be able to be simplified to 3 to 2. Listen, total perimeter is 150. Add them all. 3x plus 2x plus 3x plus 2x is the perimeter. Is 150. 10x is 150. X is 15. So therefore, the dimensions, the length of the sides, one side's 3x, which is 3 times 15, which is 45. The other one's 2x. 2 times 15 is 30. Let's see if what's the ratio of my sides? Just to put it all in, 45 to 30. Sorry? They're not that hard yet. Tomorrow we do harder ones. So the ratio of the sides is 45 to 30, which if you divide them both by 15, you get 3 to 2. Shh. Okay. Shh. Girls, please. Shh. Okay. So again, we've used one pronumeral. I wouldn't use 2 pronumerals in this one. You'd have to put x and y is 3 on 2x or something, and it's too complicated. Shh. Okay, girls, I'm looking for another problem. Ah. Okay. Shh. I don't know. A rhombus are such that one diagonal is 14 centimeters longer than the other. Now, do you want to use the 1 pronumeral or 2? I would just use the 1. Girls, I would just use the 1. So, so the shorter diagonal is what? X, and the longer diagonal is x plus 14. So we've decided we're just going to use 1 pronumeral in this one, and that's okay. Shh. Oh, this isn't hard. So the diagonals of a rhombus are such that one diagonal is 14 centimeters longer than the other, and the sum of their lengths. The sum of the lengths of what? The diagonals. So x and x plus 14 is 46. Easy. Sometimes, girls, it's easier to use the 1. Obviously, if you're doing 5-cent coins and 10-cent coins, you can't use 1 pronumeral. If you're using apples and peaches, you can't use 1 pronumeral. If you're doing ages and if you're doing lengths, girls, so, can you listen? Age, questions and shapes. Parallelograms, squares, rhombus. Use 1 pronumeral, just for those ones. Everything else, use 2. 2x is what? 46 minus 14. 2x is 32. X is 16. Therefore, x plus 14 happens to be 30. And it works. Oh, yeah, I didn't think it would be this far down. Oh, yes, let's see what you're going to do. All right, this is a good one.
Rhombus diagonals bisect each other.
At?
Right angle.
Okay, good. Shh, we're not finished. Find, so girls, we found the lengths of the diagonals. Girls, tell me about properties of a rhombus. All opposite sides parallel, four sides equal, diagonals bisect each other at, because rhombus is almost as perfect as a square. Good. So instead of 16 and 30, we've got 8, 8, 15, 15. So shorter diagonal is 16, longer diagonal is 30. Shh, girls, I know. Yep, girls, shorter diagonal is 16, so properties of a rhombus is that the diagonals, girls, bisect each other at right angles. Sorry. Right, I'm moving. Do you know what you're going to do? Pythagoras' theorem, right angle triangle, shorter sides are 8 and 15. You want the perimeter of the rhombus. Shh. Girls, do you know what we're doing? I'm turning the page. One sec, and I'll give you homework. Shh. I'm just going to set easier homework. Yeah, we're going to finish up. So this is what we've got. 8, 15. Pythagoras' theorem. C squared is 8 squared plus 15 squared. Was the answer 7?
Is 289 and the 17.
Yep. C is square root of 289, which is 17. Therefore, the perimeter is what?
Is 68.
Excuse me. 17 times 4, which is 68. Because that's the length of one of the All right, homework. Girls, please. I'm going to set questions from 1, 2, 3, 4. Are you listening? I will, but I need to look at my screen. Have you got all that, girls? Yeah. All right. Exercise 13.5, Year 9 textbook. Question 1, C and E. Question 2, B, G, L. Question 4, A, B, D. Tomorrow we do questions 3 and 5 and whatever else there is. Thank you. Natasha's book, and this is what we did at the beginning of the lesson. Exercise 13.5, question 1F. You can see that. Question 2A. You can pause the video and copy that. And question, coming up with question 2C now. Please copy out question 2C as well. That's what we did at the beginning of the lesson, so please get those down and then also get the rest and do the homework. Thank you. And that's graffiti.